Welcome to lesson 12 and section 8 on hypothesis testing, titled R Labs Comparing Proportions. And so we'll be doing a chi-squared test of independence for comparing proportions in a two-way table in this lesson. And we're looking at a couple of examples of that. We'll be making use of some pipe syntax. So I'm loading the Dipler package again. But also we're loading a package called janitor, which actually includes a function called tabyl, which we'll be making use of as well. That's already run. I'm just going to load in our NHANES data. Again, select just the outputs and then select the variables using some pipe syntax to get our analysis vars. The variables we'll be looking at are race, education, and gender. We'll be looking at analysis of a two-way table of education against race and education against gender. And we specifically, for education, we're looking high school and college grads, and race, black and white. Okay, selecting those observations, and let's take a little look at what we have. So this is the data we'll be analyzing, just looking at the first 6 observations. All right, so the first thing you need to do is, for analysis of two-way table, is actually produce the table and look at the counts. And so what we have here are the counts. We can see at a glance the proportion of females versus males or college grads are pretty much the same. But we'd like to see that proportion, and we can see that as a percentage, making use of this tabyl function. The first argument to the tabyl function is the data frame, and then list 2 variable names, and then pipe syntax into a function called adorn underscore percentages, which simply gives us the column percentage, putting in the argument where the columns col. And that's what we want. Specifically, this function here, adorn underscore PCP for underscore formatting, with the argument digits equal to 2, simply gives us our percentage to 2 decimal places. All right, so that allows us to see more clearly the percentage difference between the 2 groups, males and females, in terms of the percentage college grads and high school, but we're focusing on college grads. And so we see here very little difference between the 2. And we're unlikely to find a statistically significant result from our chi-square test of independence. Okay, so next thing, let's run the chi-square test of independence. The function for doing that is CHISQ.test the function. And we simply provide the 2 variable names as arguments to that function. Analysis underscore vars $ education, and the same analysis underscore vars $ gender. And I'm going to save it out to this object. It's I call it a HTest object. That's the class of this object. I call it a test. Before we look at the analysis results, we just want to check the expected values to see that they're all greater than or equal to 5, which they should be in this case because we've got a very large data set here. The expected values are part of that object, so we can access them in this way, save them out, and then just print them. And so we see here, these are the expected values, all much greater than 5. Our analysis is valid from a sample size condition point of view. Mentioned previously, this is quality random data. It should be independent measurement. Our data is valid for analysis, and so let's print the chi-squared analysis. We see, as expected, the chi-squared is much less than 3.84, which is a line in the sand for statistical significance, where the p-value would be less than 0.05. The p-value is much greater than 0.05. There's very little evidence in this data of an association between gender and education in the population. It's most likely population portions are much the same portion of males and females that are college graduates in the US. Okay, so now just let's look at education level and race, again, beginning with the table of counts. Now, at a glance, we see much more of a difference in the proportion or percentage of blacks, Americans that are college grads versus white Americans. So running the tabyl function again, just replacing gender with race, we get a more clearer sense of this in terms of percentage of blacks, Americans that are college grads versus white Americans that are college grads. The percentage of black Americans that are college grads, 37.25% versus white Americans, 60.96%. Quite a sizable difference as sample proportions or sample percentages. Going to find very strong evidence in association. Again, just to be consistent with the last example, let's save out the chi-squared analysis, look at the expected values, all greater than 5. And so let's look at the analysis results. And we see that the chi-squared is very large, way bigger than 3.84, and a tiny p-value. And so we have found very strong evidence of an association between these two variables, and it relates back to what we saw in comparisons of means analysis, that the average income for African Americans is much lower, household income much lower for African Americans versus white Americans. Education also we saw does determine income to a fair degree. All right, well, that's it for this lesson. Until our next lesson, enjoy your day.